Hello, I'm Malespina from the University of Pittsburgh. This is my presentation on the additional benefit of working in same-gender groups on student self-efficacy in an introductory physics that I worked on with Dr. Chandralekha Singh. A little bit of background. Women have made up about 20% of physics bachelor's degree recipients for decades. We know that this underrepresentation is not due to a lack of ability, as women are well represented in similar fields like math and chemistry. Underrepresentation of women in physics and other fields like engineering are instead due to socio-cultural issues, like lack of encouragement from friends and family, stereotypes about physics and engineering, and if a woman is multi-talented, she may feel more welcome in other subjects and departments that have a better culture. Linked to this underrepresentation are gender gaps in motivational and environmental factors, like belonging, self-efficacy, and peer effect on self-efficacy. These gender gaps exist when controlling for performance, and reporting high scores for these factors mean that a student is more likely to take physics classes in the future and to choose a career in physics. If we want more women to enjoy and pursue physics, we need to create classrooms that allow more women to gain confidence in their abilities and feel as if they belong. One possible way of raising these motivational factors in women is by pursuing same-gender group work. There has been research done on students in engineering classes by Gupta that show that when women work in groups with other women, they have less anxiety, talk more during group work, and have raised engineering career aspirations. So we wanted to see if this also created a more equitable environment in the physics context as well. A quick review of the motivational factors that we used for this study. We used self-efficacy, which is a student's belief in their ability to succeed in a physics-related task. Belonging, a student's impression of being valued, respected, and accepted in the classroom, and peer effect on self-efficacy, how a student's self-efficacy is affected by interactions with peers. Peer effect on self-efficacy has not been studied as much as self-efficacy and belonging, but it can be of the utmost importance in large classrooms because students interact much more with their peers than with their instructor or their TA. We had two research questions for our study. The first is, does gender predict self-efficacy, belonging, or peer effect on self-efficacy? And two, how is peer effect on self-efficacy predicted by whether students prefer to work alone or in mixed or same-gender groups when they were given the choice? A little bit about our methodology. We used survey data over 4 semesters of Calculus-Based Physics 2, an electromagnetism and optics course taken mostly by engineers and other physical science majors. We validated the survey before and used it in several past papers, and most questions are answered on a Likert scale. We also have a question asking if students worked alone in same-gender groups or mixed-gender groups when they had the choice. So if they had in-class clicker questions with a partner or something like that, that wouldn't count as group work, but if they had a study group that they chose to take part in, that would. On the right, we have our breakdown of students. In total, we had about 1,800, 35% women and 65% men. And looking at our chart, we can see some interesting trends that we weren't looking for initially. We can see that men are actually much more likely than women to work alone, and women are much more likely than men to work in mixed gender groups. So a quick sample of our survey questions. We have 2 examples of each. So for self-efficacy, if I study, I'll do well on a physics test, and I understand the concepts I've studied in physics. 2 examples for belonging are, sometimes I worry that I don't belong in this physics class, or I feel comfortable in this class. And our examples for peer effect on self-efficacy are, my experiences and interactions with other students in this class increase my confidence that I can succeed in physics, and my experiences and interactions with other students in this class increase my confidence in my ability to do physics. So some of our results. We have the mean scores of post-belonging, self-efficacy, and peer effect on self-efficacy. Men's belonging is practically identical regardless of group work type, and women had the same belonging if they worked alone or in a same-gender group. The sense of belonging was slightly higher for mixed-gender groups for women, but this group also had higher belonging coming into the class as well. Women all had belonging decrease by a similar amount, and men's was consistent. Women also appear to have lower self-efficacy than men by the end of the course, and group work type did not affect self-efficacy, or mean values of self-efficacy. Women also had lower peer effect on self-efficacy than men, generally. So these gaps represent a failure of the instructor and the department to create an equitable classroom environment. What can we do about this? The first is to implement group work that encourages students to take on an expert role, things like in-class presentations or students teaching each other concepts in small groups. Individual accountability is something else that's very important in this context. Students can learn from each other, but group management is often done by women. They're often the ones keeping groups on track and focused and making sure nobody's on their cell phones. This group management does nothing for a student's education and may make the managing student feel frustrated and disrespected. So we need to implement individual accountability, perhaps peer reviews by students, or quizzes that they have to do individually, so we're making sure that every student's in charge of their own learning. How is peer effect on self-efficacy predicted by whether students prefer to work alone or in mixed or same-gender groups? We performed a multiple regression analysis where we predicted peer effect on self-efficacy with gender, group type, pre-self-efficacy, post-belonging, and interaction terms. The effect on peer effect on self-efficacy here is our standardized beta term. The greatest predictor of peer effect on self-efficacy was belonging, followed by working in a group and the interaction between group work and belonging. Pre-self-efficacy and gender were smaller effects, but they were still statistically significant. An important note is that while working in any group had a positive correlation on peer effect on self-efficacy, the correlation was stronger for same-gender groups. This means that we always want to encourage students to work together, but we should also encourage students to work in same-gender groups when it's possible and convenient. This interaction term also only affected same-gender groups. The interaction term, which I have a visual of here, you can see same-gender groups. This red line has a slightly higher mean than students that worked alone. The slope is also smaller. We can call this a sort of protective effect against low belonging. If a student worked in a same-gender group, they were likely to have a higher peer effect on self-efficacy, even if they had low belonging. You can see the effect mostly here at the low end of belonging. The lower students' belonging, the stronger this effect is, and it disappears for students with a high sense of belonging. What this means is that if students have a low sense of belonging from other sources, perhaps societal stereotypes, how they're treated by their instructors or their TAs, students who work in same-gender groups are less likely to report low peer effect on self-efficacy. This is really good news for instructors because in these cases, low peer effect on self-efficacy doesn't appear to be coming from like homework or study groups. And we have much less control over the student interactions there than we do in other settings like class or office hours. So we saw 2 slides ago that working in any group is beneficial, but working in a same-gender group is even more so. This result is the same for men and women, but the mechanisms might be slightly different. If a woman is teaching other women, she's likely taking on an expert role that may increase her peer effect on self-efficacy. And if a woman is learning from a more knowledgeable woman, she may be experiencing stereotype inoculation. She is a positive peer role model that defies stereotypes about women in physics. And women with similar skill levels working together may be experiencing a mix of these effects. We also theorize that women that talk and participate more in same-gender groups, leading to more confidence and less anxiety in physics. Men also experience this positive effect from working in same-gender groups. There's been some research in psychology that men will feel threatened if women perform better than they do in a stereotypically masculine activity, so that may be what's going on here. So what's next? So we know there are gender gaps in belonging, self-efficacy, and peer effect on self-efficacy at the end of the course. It's our job as instructors to improve the classroom environment to decrease these gaps. Examples of these improvements are encouraging students to take on an expert role and implementing individual accountability that we talked about earlier. The other big takeaway from this is that working in a group, especially if same gender, leads to higher peer effect on self-efficacy. This means that we need to encourage any student working alone to find a group, and we should also implement classroom policies that increase equity in mixed gender groups. Again, peer teaching, individual quizzes, or peer review that we talked about earlier. For future work, it's important to find what group mechanics increase motivational factors and if these mechanics are gendered at all. And we should do this while remembering that our ultimate goal is to create a classroom that decreases or eliminates societal inequities rather than perpetuating them. Thank you so much.